Happy Wednesday. That is also like a happy Friday because you're about to start your spring break. What? Okay, that's enough corniness for now. Um, so let me just get you excited about this fun lesson that we're about to jump into 5.16. We are finally getting into something other than volume and area. We're getting into angle measurements. We're getting into different shapes, sides, words like parallel, vertices. There's so many. I'm so excited, and I hope some of this excitement rubs off on you, especially as you're going to be challenged. No lie, this is going to be a little time consuming. At times it's going to seem like it's too hard, but I promise you, just take your time. You'll get it. We're not looking for perfect answers. We're looking for your best work. Okay, so let's jump right in. See you in office hours. Okay, let's get started. Let's set our timer. 4 minutes on the clock. Do your fluency. When I say go, push pause. Press start on your timer and complete this fluency page. Go. Excellent job. Now we're up to our Thrive Point Challenge. Today we're challenging ourselves with the multiples of 12. With the multiples of 12. Don't let that number scare you. You got this. Set your timer. 2 minutes. See how far you can go. Try to finish the entire page. Go. See, I actually pushed pause, but I unpaused myself because I have a feeling there's someone that didn't push the pause button. So when I say go, really push pause. Challenge yourself. You got this. Go. Great job, Thrivers. I really just came up with that name. From now on, you are my Thrivers. Okay, let's stop being corny, Mr. Bautista. Let's just jump into our application problem, please. Yes, let us read and annotate together. So to do it together, please make sure you have a paper in front of you with a pencil that maybe you have a printed packet. Maybe you should write out the question before we annotate so that way we can be on the same page. So if you don't have this already written out, push pause, write out the question, go. Okay, I hope you did it because we're moving forward. Kathy spent 3/5. I'm going to write that as a fraction. Again, if you were in my office hours yesterday, you know I'm having some pen difficulties, so just bear with the sloppiness for a day. I appreciate you. So Kathy spent 3/5 of her money on a necklace and 2/3 of the remainder on a bracelet. Remainder, remember, means what's left. What's left. That word is left. That is the remainder. If the bracelet cost $17, how much money did she have at first? Okay, this problem is revisiting a lesson that we've done, that we did a while back. We're going to revisit the land of tape diagrams. So let's start by drawing our tape diagram. Remember, the way we divide our tape diagram to show our total unit, we look at the denominator. That'll let us know how we are dividing into equal parts. So Kathy spent 3/5 of her money on a necklace. So we're going to divide our tape diagram starting with 5 equal parts. That means 4 lines. Okay. 3/5 of her money was spent on the necklace. So we have this 1/5, this 1/5, and this 1/5. Right? All that was spent on her necklace. We'll just put an N. 2/3 of what was left was spent on the bracelet. 2/3. So now we see the remaining two parts because they're not filled in with red. So those two parts now we have to divide to 3 equal parts. Dividing into 3 equal parts. Where did I get the 3 from? From the denominator. Excellent. So 3 equal parts means 2 lines. So we separated the 2 remaining fifths into thirds. And it's saying 2/3 of what we have remaining is what she spent on the bracelet. So how do we find out 2/3 of what is remaining? Well, how many parts are represented? Let's count. 1, 2, 3, 4, 5, 6. We have 6 parts. And so what is 2/3 of 6 parts? What is 2/3 of 6 parts? Instead of, I'm going to use multiplication of 6. We multiply. We already did a whole fluency page of problems just like this. So 2/3 times 6 equals 12/3. And that is equal to 4. Okay, so 4 parts are 2/3. So now let us shade in 4. 1, 2, 3, and 4. That is our bracelet. And that is also, how much did she spend on the bracelet? Very good. $17. Excellent job. Match my work. 5, 4, 3, 2, 1. Good. So how much money did she have at first? So now we know those 4 parts, right? The 2/3 of the remainder is $17. When we broke down those parts of the tape diagram, those were divided into thirds. Those were divided into thirds. So we are going to now divide the entire diagram into thirds because we cannot solve a problem with different units, right? Everything when whether we're adding or subtracting, just like in fractions, you have to have a common denominator. Same thing in a tape diagram. You have to have equal parts to represent the whole. So right now, I'm dividing each section into 3 equal parts. And now we just need to find out what is one of those parts. I'm going to put that in with an arrow. We're looking for one of those parts. So if $17 is equal to 4 of them, how do we find out what is one of them? If $17 is 4 of them, how do we find out one of them? Very good. We divide. We divide. 17 divided by 4. When you find that result, that's going to be for one of our parts. How many total parts are there in this entire diagram? Count them. If there's 3 in each box, and there are 5 boxes, 3 times 5 is? Very good, 15. So first, let's go back to our 17/4. That'll tell us what is one part. When you find that answer, right, let's put a gray star in there. When you find that answer, you're going to multiply that by 15. Oh, wait, hold on. And that'll tell you how much money did she have at first? Push pause, rewind, because I know I said a lot. Just do your best. Take your time. Take a deep breath in. Go. Excellent job pushing through, really striving for thriving. Okay, now we have question 1. It says sort the polygons by the number of sides. So on the left side of the screen, you're going to see letters A through O, and you're just going to plug in those letters. I know the chart is twisted a little bit, but it's okay because you're working on your own paper. I just wanted to fit everything on one screen because all of this is done on your own. You're putting where each letter goes. So if letter A, how many sides does letter A have? Very good, it has 4 sides. So on your piece of paper where you wrote down 4 sides, you're going to include the letter A. Complete the rest of this page. Or if you want, you can, inside the picture, you can also just write the number of sides. I just thought about that. I think I got that from talking with Miss Brotman. I think she did it like that as well. Okay, push pause when I say go and finish the page. Go. Oh, sorry. Excellent job. Let's read together. A trapezoid is a quadrilateral, or shape with 4 sides, in which at least one pair of opposite sides is parallel. Okay, now these are words and shapes that should be bringing back some memories of the 3rd grade, 4th grade. This is not totally new information, so let's refresh ourselves. What does parallel mean? Let's look at shape A. Parallel means that the lines that are drawn, if you continue them, they will continue to go to remain next to each other, going in the same direction. As you can see from the lines that I started to draw, both sets of lines are continuing to go in the same direction next to each other. So yes, shape A is a trapezoid, so you will put A in the box. Now you'll go on to B and complete all the way to letter O. Well, since I said the letter O, let's just start drawing our lines. There is not at least one pair of opposite sides that are parallel. So right off the bat, we know we could put O in our non-trapezoid box. Okay, that's enough answers from Mr. Bautista. When I say go, push pause, finish reading this chart that says formal definition of a quadrilateral, and then complete your trapezoid and non-trapezoid chart. Go. Excellent job completing that page, filling in your trapezoid and non-trapezoid chart. You know, I actually really like saying the word trapezoid. Who came up with that name? Trapezoid. I'm sorry, those are things I just think about sometimes when I just don't want to do anything else. Probably like you really don't want to complete this packet right now, so that's why I gave you a little break just going on a rant about the word trapezoid. But now we move forward. Question 3. What are polygons with 4 sides called? What are polygons with 4 sides called? Number 4. Which shapes are quadrilaterals? Number 5. What attribute do you need to consider to separate the quadrilaterals into 2 groups, trapezoids and non-trapezoids? I think some of you are going to have to, like I did, look up the word attribute. What attribute do you need to consider to separate the quadrilaterals? If you're stuck also on the word quadrilaterals, that means question number 4 also has the word quadrilaterals. I hope you took some time and really looked up that word. Because if you go back to the other screen, oh, look what it says in this chart. The formal definition of a quadrilateral. Formal definition of a quadrilateral. Definition means what does it mean? Okay, so now you're reminded of what is a quadrilateral. So now you can accurately check and answer question 4. And if you need to look up the word attribute for 5, please do so now. And then question 6 says, how are the shapes in the trapezoid group alike? And how are they different? Now would be a great time to push pause, sharpen your pencil, maybe rewind so you see that gray box again that gave you the definition for quadrilateral, look up the word attribute, and then complete questions 3 through 6. Ready? Go. We have now made it to our problem set. Question 1, or problem 1. Draw a pair of parallel lines in each box. Then use the parallel lines to draw a trapezoid with the following. Again, draw a pair of parallel lines in each box. Again, parallel lines, if you look at the space on the right, are lines that continue next to each other, going in the same direction, equal distance apart. And then we have to also remember what is a right angle, right? A says no right angles, but if you don't know what a right angle is, you're going to have a problem. Right angles are all the angles that make up rectangles, right? So it's like the letter L. Well, that's not a really good example because I'm trying to do this as straight as possible, right? So those are two straight lines, and then the red semicircle, that is the mark that we put for an angle, and that is a right angle. So A says no right angles. B says only one obtuse angle. What is obtuse? Let me just write in the word. This is a right angle. Right angle. That little symbol means angle. Okay, so obtuse angle is two lines that the angle is greater than 90 degrees. It's greater than 90 degrees. All right, so this would be an obtuse angle. And remember that symbol that I just drew now, that means angle. Okay, so now you have all the information you need. You have the green lines, those are parallel lines. You know what a right angle is. You know what an obtuse angle is. So remember, it says draw a pair of parallel lines in each box. Then use the parallel lines to draw a trapezoid with the following. So maybe you need to go back and remember, what is a trapezoid? I know I've read it 3,000 times. Maybe you need to read it 3,001. When I say go, push pause and complete A through D. Go. Excellent job. Now, I really hope you're still with me. Let's take a deep breath in. Oh, I can't do it because I'm super excited. Because if you look at the screen, question 2 says, use the trapezoids you drew to complete the task below. Then you see in the parentheses a website. Go to that website right now. It is so much fun. I don't even want to give it away. Once you type in that website, you're going to see what the excitement is all about. You're going to be able to do so much on your own. So please also make sure you have your pencil sharpened. You have a fresh piece of paper. You're going to want to take notes. You're going to want to write this down. So when I say go, immediately push pause. Go to that website. And just like it says in the first line, math is fun. It's not a lie, I promise you. Ready? Go. Here we have questions 4 and 5 from our problem set. Take your time. Read the question completely. Annotate. any word that you do not know what it is, look it up. You have google.com, you have dictionary.com. Maybe you're still, like my house, my parents still have dictionaries in book form. I'm going to underline some words that maybe you should look up because I don't think you're really going to remember because some of these words are from the third grade. Okay, so number 4 says, when can a quadrilateral also be called a trapezoid? Now, quadrilateral and trapezoid are already words that you should know because we looked them up already before. Okay, number 5, follow the directions to draw one last trapezoid. So all of these instructions are to draw one trapezoid. Draw a segment AB, that's how you're going to label it. So if this line is a segment, A, B. Right? That's how you label it. You label it at each side. Okay. So again, A, draw a segment AB parallel to the bottom of this page that is 5 centimeters long. I'm just underlining that because it sounds important. Draw, part B, draw two 55-degree angles. Now remember, you can go back to that website. They should have information on what a 55-degree angle looks like. Draw two 55-degree angles with the vertices at A and B so that an isosceles triangle is formed with AB as the base of the triangle. C. Label the top vertex of your triangle as C. Label the top vertex as your triangle as C. D. Use your set square to draw a line parallel to AB that intersects both AC and BC. E. Shade the trapezoid that you drew. Push pause, rewind, look up all the words that you do not know. Do your best. Remember, I'm not looking for a perfect answer. I am looking for your best work. So that means I'm looking forward to seeing whatever your amazing mind has put together for this trapezoid during office hours. I'm looking forward to it. So push pause, go. You have made it! Your exit ticket. A. Use a ruler and a set square to draw a trapezoid. Simple, easy peasy, lemon squeezy. B. What attribute, there's that word again. You should already know what it is because I'm sure you looked it up. Okay, sorry. What attribute must be present for a quadrilateral to also be a trapezoid? Did a great job today. Super proud of you. Look forward to seeing you during office hours. Bye.